So let's talk a bit about MVC, Model View Controller. The separation of concerns here is that we have a model component that will deal with the data in the system, a view component that deals with how that data is presented, and a controller component whose job it is to organize things. So the model will deal with the data and the related business rules for updating and retrieving that data. And that is separate from the view, whose job it is to present that data to the user. And both of these are separate from the controller that manages the user interaction. So there we have the separation of concerns. We've got responsibility defined. Model is responsible for data and the related business rules. View is responsible for presentation. Controller is responsible for management. So they've got their individual responsibilities, quite distinct, no overlap, and there is some communication between them. So for a given user interaction, the controller should normally activate one or more model components and then activate one or more view components. So we're starting to see then that there's some interaction because the controller is going to be activating these. And so we could have a configuration that might look like this. Step number one, there'll be some input from the user that comes into the controller. The controller decides what kind of input that is and will then, in some way or another, activate a model component. In this particular example, the activation consists of an update. That model will then do what it does with the data according to the business rules, and then the controller will cause the view to be refreshed. And as part of that, the view will need to read that data. And the view's final job is to output to the user the results of that interaction. Let's consider separation of concerns a bit further. We have the global separation. Model is separate from view, both are separate from controller. But at the lower level, there's still this separation of concerns. Let's consider, for example, only the model components. Each individual model should perform one functional operation, and that's it. So instead of having a component that will update and retrieve customer details, we should use two separate components. Both of them are model components. One will be responsible for updating customer details. The other will be responsible for retrieving customer details. Those two components are functionally separate. They might be operating upon the same data, but one of them will be updating, the other retrieving, so they're quite separate. The advantage of doing that, of course, means that having separated them, we now have a component that is reusable. The retrieve customer details component could be used in all kinds of different places without having to be coupled to the update first. And we can do a similar thing with separation of view components. So here we have another example. The update customer request comes in to the controller, whose first job will be then to activate the update customer model component, who will write to the database. Then the controller will activate the retrieve customer component. This is a model component that will then extract from the database that information that has just been written to it. Then the controller can cause the customer view to refresh that will get the information that has been retrieved here and then output it. Another example, request 1 comes in. The controller will activate the model and then the view that relates to that request. Then a different request comes in to the same controller, and this time, having distinguished that it's a request type 2, it will activate a different set of model components and view components. So we can see here then that we could have, in this particular example, a controller that interacts with the user, receives all the requests that come in, and will then activate a different set of model and view components depending upon which request has been received. There are all kinds of ways in which we could configure this. We might, for example, decide to have a single controller for each interaction. But for now, I think we'll probably stick with this last configuration. So having identified the architecture that we're going to use and discussed its principles and the way the components interact with each other, now we've got to think about how to take that abstraction and apply it to our implementation. With our internet applications that are written solely with Java servlets, the model, view, and controller components are all going to be servlets. Because the controller has to be able to activate model components and view components, then we have to work out how one servlet, that will act as the controller, can then invoke model components and view components. And with servlets, there are three ways of doing this. We can use the include mechanism, the forward mechanism, or the redirect mechanism. To include a servlet, we need, first of all, to declare a request dispatcher object. Create the object by calling from the request parameter that comes in as a parameter to the do post or do get method. From that object, we call get request dispatcher. And we pass to it a string, which is the URL of the servlet that we want to activate. This method will then return a dispatcher object that is set up to target that URL. And then we can, from the dispatcher object, call the include method and pass the request and response objects that we are currently dealing with. And so what we can see here is that this servlet, which is, let's say, the controller servlet, which has received a request object and a response object from the servlet container, will then pass those exact same request and response objects to the next servlet. So the next servlet will be operating on exactly the same request and exactly the same response objects as the original controller servlet. If we want to forward to a servlet, then it's very similar. In fact, the only thing that's different is instead of calling dispatcher.include, we call dispatcher.forward. So what's the difference? Well, it's all to do with the flow of execution. When we include another servlet, we're going to halt execution of the invoking servlet and switch control over to the invoked servlet. When that has finished executing, control then comes back to the invoking servlet. And then the invoking servlet will continue its execution from the point where it left off. Whereas with forward, execution does not come back to the invoking servlet. And so forward would essentially be the last thing that that servlet does. The redirect is a completely different mechanism because the servlet that receives the request will then issue via the response object a redirect command that goes back to the web browser, and then the web browser will issue another request for the nominated servlet to which it has been told to redirect. So in the first two examples with include and forward, when the web browser sends its request, it has no concept whatsoever about the include and the forward that might have taken place. As far as the web browser is concerned, it sent in a request to the controller servlet and it got its response from the controller servlet. All the internal workings of the forwards and the includes are completely transparent to the web browser. It knows nothing of them at all. On the other hand, with the redirect, the web browser sends the request, the controller then sends back a message to say redirect to this other servlet, and then the web browser sends a second request, but this time to the other servlet. So it's a completely different mechanism.